Alright, 6.7, linear systems. When we're looking at linear systems, we're going beyond just looking at one line, and we're looking at a linear system that is a set of two or more linear equations. So basically two or more lines that are considered simultaneously. So they're considered at the same time. So in the case of a linear system in this unit, we're going to be graphing two lines and finding something called the point of intersection. The point of intersection is the point where two or more lines cross. The POI, point of intersection for short, is POI, is a solution to the system. So we're going to be finding solutions to systems by graphing. So let's look at an example right away. Example 1. You're asked to determine the solution to the system. And you're given the equations. Here we go. Y equals 1/2 x minus 3 and x plus y plus 6 equals 0. And you're to check your solution. Alright, so when you're graphing, you'll be given a graph and you'll be given the system that you'll have to graph. When you look at the system, when we're graphing them, we have to make sure that the equations are in slope-intercept form. So let's take the two equations and write them out and call the first one 1. So y equals 1/2 x minus 3 is equation number 1. And we can identify the slope right away, which is m equals 1/2. And we can identify the y-intercept, or the b. The b value is -3, which is the y-intercept. Then we need to do the next one. We need to find the next, look at the next equation. You notice that this equation is in standard form. We want to put this in slope-intercept form. Slope-intercept form means we need to put the y by itself and everything else to the other side. That is y equals -x minus 6. So again, we left the y here. We moved the x over, became -6, and we moved the plus 6 over, became -6. So -x minus 6 is the equation y equals. And we can identify the slope, which is m equals -1. And we can identify the b value, which is -6. Well, how's this going to help us? Well, folks, you'll be given a graph. So we need those coordinates. Remember that the b value is actually the coordinates. They are the y-intercept. So we're going to begin at the y-intercept. So here is our grid. And we need to graph these two equations of the lines onto this particular graph at the same time. So it's not two separate graphs, folks. It's two lines on one graph. That makes it a system. Now, let's keep in mind, we will always begin with the B, begin. That will begin on the y-axis. These numbers are on the y-axis. The coordinates for for the y-intercept are these. And we want to graph number 1. And we're going to do that by beginning at 0, -3. 0, -3 is right here. And I'm going to follow the slope, up 1 over 2. Put a dot there. Do it again. What we're going to do is follow it again and say, all right, here we go. Up 1 over 2, and there's another dot. Up 1 over 2, there's another dot. Up 1 over 2, there's another dot. Up 1 over 2, there's another dot. And up 1 over 2 for the final. Are we done? No, we're not, because we need to go now backwards. So, starting with the first dot we started, we go backwards. So it's down 1, back 2, down 1, back 2, down 1, back 2, down 1, back 2. And there we go, folks. We now have plotted all the points from left to right all the way across. We connect those dots with a line and we put arrows at the end. And we name the line. That would be equation y equals 1/2 x minus 3. That's equation number 1. So we've now graphed our first line, and we do the same for the second line, and we're going to use that in blue, folks. So we begin at -6. So this is where -6 starts right here, and we're going to follow the slope. The slope is down 1 over 1, down, and then start again, down 1 over 1. And then we're going to do that again, down 1 over 1, down 1 over 1, and so on. And now we go backwards, folks. So up 1, back 1, up. Oh, look at that. We've hit the other line. But folks, we need to continue, and we'll color that in a new color so that we know that this is a very special point. We will deal with that one a little bit later. But we need to continue our blue line in the meantime, and we continue it by putting all these dots here, folks, and we can see that we have arrows at the end of it, and this is our blue line, which has the equation x plus, so the original equation was x plus y plus 6 equals 0. That's the original equation, so that's the equation we write it with. But most important, we notice this dot right here. This red dot is so important because this is the solution to the system. It is the point of intersection. It is our POI. So this is our point of intersection or solution. Therefore, the solution is -2, -4. This is the point right here. Now, notice up here in the question, it also asks you to check the solution. And we'll do that on the other page. All right? Here we go. We're going to check the point. And we need to check it in for x and y in both equations, in 1 and in 2. So we have to check it in 1 and 2. We're checking -2, -4 for x, y in 1 and 2. How do we check? Well, we must perform something called the left side, right side check. So we create a left side, right side table, and what we put on the left side is y. On the right side, we put 1/2 x minus 3. So where does this line start? It is always where the equal sign is, because it's the left side and the right side of the equal sign. You always do a check in this format, because what we're doing is we're checking to see, does this point make the left side equal the right side? That's the whole point behind doing this, folks. So we do need to do it in this format, and no other form is acceptable. Well, the reason why is you can't say it's equal to something until we can prove it actually is equal. That's what the point behind doing a check is. So left side is y, the right side is 1/2 x minus 3, and you plug in the values. So y is going to have -4. Remember that we're plugging in y for -4, and then on the other side we're going to have 1/2, and instead of x we're going to put, that's right, for x we're going to put something there, and then -3. So what are we going to put in for x? We're going to put in -2. So now that we have that, what we can do is solve for the right side. So 1/2 of -2 is -1. -3 gives us -4. And folks, do you see what I see? Yes, I hope you do. The left side equals the right side. And we have now checked it, that it's equal. And guess what? That has made us happy. So folks, we can say that yes, definitely, -2, -4 is a solution for equation number 1. Equation number 2, x plus y plus 6 equals 0. We need to do the same thing. Left side, right side. Left side, right side. The left side is x plus y plus 6. That's the left side of the equation, equal sign. The right side is 0. That's the right side of the equal sign. Now what you're going to do is plug it in. You're going to plug in x is -2 plus y, which is -4, plus 6. So -2 plus -4 plus 6 is equal to, that's right, 0. Do you see what I see? Oh, yes, I'm sure you do. You see that left side equals the right side. We have checked that it's equal, and that's made us happy. All right, well, because we've checked that it's equal and it's made us happy in both equations, we can make a final statement saying that therefore, -2, -4 is verified as the solution. All right, let's try another example. Example 2. A couple has budgeted $15,000 for their wedding reception. Which hotel offers the better deal and under what conditions? So we got American Inn and Osage Hotel. American Inn has a $5,000 base fee just to rent the hotel conference room for the wedding. That's a base cost. Plus, there's a $100 fee per guest attending the wedding. Whereas Osage Hotel has a $3,000 base cost plus $120 per guest. So in both cases, there's a time when American Inn is better than Osage Hotel. And other times where Osage Hotel is better than American Inn. And that's what we need to find out. To do this, we need to set some statements. For example, we need to find equations. So we're going to let X represent the number of guests attending the wedding. And we're going to let Y represent the total cost. So the cost in money. So both hotels have a cost. What is the cost? The cost is Y equals 100X, so $100 per guest, plus $5,000. That's American Inn. Osage Hotel starts with $120 per guest plus the $3,000 base fee. So there's our two equations that we need to be able to find the solution. All right, we're going to now move to the next page where we're going to graph these two equations. So we have a graph here, and with something like this, you'll be given the graph set up for you, okay? So you'll be given, right now you'll be given a graph, but it will be expected sometime in your math career to be able to do this by sketching a graph right from the beginning. Okay, so with this example, we find that $3,000 is our base cost and $5,000 is our other base cost. That is the flat cost that you have to pay to be able to rent this hotel. Next thing we're going to do is we're going to find out how much it will cost for, let's say, 100 guests. 100 guests means you take 50, so we need to, we know, sorry, not 100 guests, but we know that we can have $15,000 maximum to pay for this hotel. We have $15,000. That's all we can pay, folks. $15,000. That's the allow. How much we have to be able to have a wedding at any one of the two hotels. So what we're doing is taking the cost, the $15,000, that's our max cost, and we're going to set it equal to the equation 5,000 plus 100x, or 100x plus 5,000. What we're trying to find out is how many guests we can have at American Inn to be able to spend $15,000. So we move the 5,000 over, we get 10,000 is equal to 100x, and that means when we divide by 100, x is equal to 100. So once we divide by that 100, we find out that x is equal to 100. That means that at American Inn, $15,000 will give us a maximum of 100 guests. Let's go to the other one. So there it is. There's our equation, and we know at 100 guests, it will be $15,000. Let's try the other equation. So $15,000 is equal to 3,000 plus 120x. Well, we subtract the 3,000, we get 12,000 is equal to 120x. Divided by 120 gives us 100. Luckily for us, at 100 guests, folks, at 100 guests, we can see that they both reach $15,000. If your budget was higher, you can invite more guests. if your budget is lower, you can invite certain number of guests. So let's look at which deal is better and when. So in this case, what we'll see is that this red one, the red one being Osage Hotel is actually cheaper up to 100 guests. So it's consistently cheaper up to $15,000. So Osage Hotel is the better deal up to $15,000. If you were to spend more than $15,000, well then that's when American Inn turns out to be the better deal. Because you can see that the American Inn line actually goes below the Osage Hotel line. So Osage Hotel was in red and the American Inn is the blackish gray line. So Osage Hotel is actually better if the wedding has less than 100 guests, so up to the $15,000 budget. American Inn is better if you plan on spending more than $15,000 because it is better if the wedding has more than 100 guests, so more than the $15,000. Both places now cost the same at $15,000 when 100 guests attend the wedding. So if you're going to have 100 guests, it doesn't matter which hotel you go to. If you're going to have less than 100, the deal is you should probably go to Osage Hotel. If you're going to have more than 100 and you're going to end up spending more than $15,000, then you better think of going American Inn. All right, folks. Well, that's the end of the video. Have a numerical day.